Hello, today is lesson 12.3. It's going to be very similar to what we did yesterday, except it's called geometric sequence in series. Now, a geometric sequence in series is when the ratio of any term to the previous term is constant. You're still going to go in the same order we did when we did arithmetic and we did subtraction. You're going to do the second term divided by the first term, the third term divided by the second term. So, for example, let's go ahead and try this. 10 divided by 4, if I reduce that, I get 5/2. Now let's do 18 divided by 10. If I reduce that, I get 9/5. Because these ratios are not equal, it is not a geometric series. So I want you to take a quick minute to pause this video and try this one. Remember, we're going to do the second term divided by the first term, the third term divided by the second term, and so on. You want to check all the ones that you're given to see whether or not it is a geometric sequence. Okay, now the rule for a geometric sequence is given as follows. You have to memorize this as well. And every time you do a problem and you write it down, you will automatically know it. So the nth term of a geometric sequence with first term a sub 1 and a common ratio r, that's what we get when we divide the second term by the first term, the third term by the second term, and so on. Ratio r is given by this equation. Again, just like as we did in the other one, it is the order of division is important, so make sure that you do that. And here's just a quick example. The nth term of a geometric sequence with the first term of 3, so notice 3 was substituted in for a sub 1, and a common ratio of 2, so we're going to put 2 in for r, is given by this. Notice, you do not multiply these two together. You do not tell me the answer is 6 to the n minus 1, because that would not be following order of operations. This exponent only goes with the 2. So we actually just leave our answer like that. That makes these problems a little bit easier. Okay, so let's go ahead and get started. I believe there's 3 types of writing rules. And again, I like to write the rule down every time I use it. So I have a sub n equals a sub 1 r to the n minus 1. We want to put in something for a sub 1, and we want to put in something for r. Now, in this problem, I'm given a sub 1. It's 4. I could find r by dividing. So 20 divided by 4 is 5. And if I give you a sequence and it says write the rule, it is going to be a geometric sequence, because I believe the directions on the test say write the rule for the geometric sequence. Okay, so just go ahead and plug it in. A sub n equals 4 times 5 to the n minus 1. Now, if you want to be in the habit of writing parentheses, it's a good thing to do, because in case r is a fraction or negative, you want the parentheses. Sometimes I forget, and when it's just positive, I don't write it. And then it says find the next term. So this is 1, 2, 3, 4. So if I want to find my 5th term, I plug in 5. So I would get 4 times 5 to the 5 minus 1. Order of operations is important. We do 5 to the 4th first. Then you multiply that answer by 4. So we get our 5th term is going to be 2,500. You want to check to make sure you do that right, because like I said, a lot of people end up doing 20 to the 4th, and that's incorrect. Order of operations, which means exponents first. Okay, go ahead, pause the video, and try this next try on your own. Okay, welcome back. The next type of problem is where you are given r, but you are not given a sub 1. So again, I'm going to go ahead and write down my rule. I'm going to plug in what I know and find what I don't know. So I know that the 4th term is 12. So our a sub n is 12. We don't know a sub 1. We know the common ratio, and we know we have the 4th term. So 4 minus 1. So go ahead, do this. So this is 2 to the 3rd power, which is 8. Can't be afraid of fractions in this lesson. We want to get a sub 1 all by itself, so we're going to divide both sides by 8 and reduce the fraction. I would just leave it as a fraction, and we get 3/2. Now I have my a sub 1 and I have my r. I can plug it in. And I would be perfectly fine if you wrote 3/2 as 1.5. That would also be acceptable. So here's the rule. Now I want you to try exactly what I did on this try. We're going to put 5 in for n. We're going to put 54 in for a sub 1, and we're going to put 3 in for r. And then you're going to solve for your a sub 1, and then plug your a sub 1 and your 3 and your r back in. Okay, now this one, again, a little bit tricky. The easiest way to solve this system is going to be by substitution. So I'm going to go ahead, write my rule down. You're missing an a sub 1 and you're missing an r. So the first thing I'm going to do is I'm going to plug this in. Okay, we're going to put negative 12 in for the a sub n, and then 2 in for n. So 2 minus 1 is just 1. Now I'm going to go ahead and do the same thing with this equation. So negative 3 equals a sub 1 r to the third. Okay, now what I like to do is I like to take the smaller exponent, so this is the top one, and all I'm going to do is I'm going to divide both sides by r. So I'm going to divide this by r and this by r. Now watch what happens. So I get a sub 1 to equal negative 12 over r. Then I'm going to take this and I'm going to substitute it into the second equation. So I'm going to get negative 3 equals negative 12, negative 12 over r times r cubed. Now look here, okay? R cubed over r is r squared, right? This simplifies. So we're going to get negative 3 equals negative 12 r squared. You want to solve for r. So I'm going to go ahead, divide both sides by negative 12. I get 1/4 equals r squared. Now I don't want r squared, I want just r. So I have to square root both sides. Now, because you're taking an even root, you have to do a plus or minus. When I take the square root of 1, I get 1, and the square root of 4 is 2. Now, I have a little bit of a problem. I have 2 answers for r, okay? So we're going to have to get 2 answers for a sub 1. So let's plug in a positive 1/2 first. I think it's easiest to plug in the one where you already have a sub 1 all by itself. So I'm going to do negative 12 over 1/2. When I do this, I get negative 24, okay? Then I'm going to take negative 12 and I'm going to divide it by negative 1/2. When I do this, I get positive 24. So you are actually going to have 2 equations in this problem. Now this doesn't always happen. This is about as messy as these problems are going to get. So the last step is you just found r. This isn't, you found a sub 1. This is a sub 1 and this is a sub 1. So we're going to take our positive 1/2 for our negative 24 for a sub 1 and plug it back in. Now the good news is there's no rearranging in this equation. So we get negative 24 times 1/2 to the n minus 1. Okay, or we're going to take negative 1/2 and positive 24. These are our 2 equations. And like I said, practice will make perfect. Every single type of problem is basically like this, except most of them we will only have 1 equation, because if you're going to take the odd root, you'll only get 1 answer for your r. I want you to take a minute. I do want to see this one worked out. I want you to try doing exactly what I did for this you try. And I will give you a hint, you will only get 1 equation, so it'll be a little bit easier. Okay, next problem, same thing here. A geometric series is the expression formed by adding the terms of a geometric sequence. You can find it by using this formula, but we don't need to do that because I am allowing you to use your calculator, so we can just go ahead and practice plugging in our summation. Now, I would like you to practice plugging in both of these using your alpha F2 and then number 2 key, because I want you to watch the parentheses. So make sure you're watching this. Make sure the exponent has the variable minus 1. In this problem, you need to make sure there are parentheses around the fraction, and you need to make sure your exponent is the variable minus 1. So try this, pause the video, and see if you get what I get. In number 1, you have 86,093,440. And in this you try, you have either 665 over 8 or 83.125. Okay, any questions, comments, or concerns, go ahead, write them on the bottom of the paper, and I'll see you tomorrow in class. And again, I don't want anyone coming in tomorrow with you tries that are blank.